Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to configure ESP32 camera module with Raspberry Pi 4 for TensorFlow Lite object detection. So as you can see, I have here ESP32 camera module. This is what ESP32 camera module, and we have here also USB microcontroller programmer, as you can see. So I have connect the ESP32 camera module with this USB microcontroller programmer. Simple, as you can see. And then for programming, we have here our normal data cable. As you can see, this is what our data cable, a normal data cable. So we are going to connect our ESP32 camera module with a Raspberry Pi 4 using this cable, and then we are going to install Arduino, and we are going to configure a TensorFlow Lite for object detection. So before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much. So friends, how to connect this USB microcontroller cable with ESP32 micro programmer board? As you can see, so this is what our cable. So this side we are going to connect with our microcontroller programmer. As you can see here, just connect like this way. As you can see, I have connected, and then this is what our USB side, which we are going to connect with our Raspberry Pi 4. Simple. So this is how you need to connect this USB cable with our programmer, our USB microcontroller programmer for ESP32 camera. As you can see, I have connected like this way. So friends, we are now on our latest Raspberry Pi Bookworm 64-bit operating system. So first thing first, as I already explained, I have connect the ESP32 camera board with Raspberry Pi 4 using USB cable. I have connect the USB cable with USB programmer, a micro programmer, as I already explained in video. So that's it. Now simply first we want to download the repository. So I will mention the link inside description box. This is what our repository. You need to simply copy paste the link inside the browser. As you can see, RPi4 ESP32 CAM TF Lite object detection. So this is the repository. Simply go to the code, click on it, it will, and then as you can see, we have here download zip. Just click on the download zip and it will download our zip format repository. As you can see, it's now downloading. So we successfully download our repository. Now simply minimize the browser, go to the file manager, go to the downloads, and this is what our repository. Right click and then click on extract. Here it will extract our repository. So this is what our folder. Right click, click on cut, go to the home and just paste it our repository. So this is what our repository. So now go inside our repository, and first what we want, simply rpi4.txt. this is what our text file. Right click, open with text editor. It will open our rpi4.txt with the help of this text editor. So first, for Arduino IDE, we want Pi apps on our Raspberry Pi Bookworm 64-bit version. So this is 64-bit version. So for Arduino IDE, we want a Pi apps. Then with the help of Pi apps, we are going to install Arduino IDE. Simple. So this is the link, install Pi apps. Just copy it. Just copy as it is, open terminal and just paste the link inside terminal, and then just hit enter. It will automatically install Pi apps on our latest Raspberry Pi Bookworm 64-bit version. As you can see, it's now installing. So friends, as you can see, installation complete, means we successfully installed Pi apps on our latest Raspberry Pi Bookworm 64-bit version. So minimize all the things, minimize it, and then go to the menu and go to the accessories, and here it is. As you can see, we have Pi apps. So go to the menu, then accessories, and then we have Pi apps. Just click on the Pi apps and it will open Pi apps, and as you can see, we successfully open our PyApps and all the menu we have, as you can see. So in PyApps, we want to go inside programming section. As you can see, the programming, just select it, programming section, and inside programming section, as you can see, we have Arduino IDE, Arduino. So just select it, Arduino, and then it will open this kind of window. As you can see, just click on install button, then it will open this kind of terminal. So now, as you can see, monitor progress installing. So meanwhile, here it is, it's asked Arduino color theme. So you can select a white theme, also you can select a black color theme. So I will choose here a black color theme. So now, as you can see, the process is started. It will automatically install Arduino IDE on our latest Raspberry Pi Bookworm 64-bit version. So it will take some time. Meanwhile, I will pause the video. So friends, as you can see, we successfully install Arduino IDE. We have done with our process. So let's just close the terminal. Let's just close PyApps. And now if you go inside menu, programming, and then as you can see, we have here our Arduino IDE. So just select it, Arduino IDE, and it will open Arduino IDE window like this way. So friends, as you can see, we open our Arduino IDE. Now first, we want to install ESP32 board on our Arduino IDE. For that, simply go here, File, then go to the Preferences, and it will open a Preferences window like this way. And in additional boards manager URL, we want to mention our URL for ESP32. So let's just open our repository again. No need to open repository because we already open our text file. So this is what our text file, and as you can see, I have mentioned here a second line which is board link. So just copy the board link like this way, just copy as it is from HTTPS to end index.json. So just copy the link, copy it, open our preferences window which we just opened, and paste the link inside additional board manager URL. Just press Ctrl+V. As you can see, we paste our link. So copy the link from text file, board link, copy, and just paste inside preferences and additional boards manager URL. Simple. Then click on OK. Then now go to the tools, and then go to the board, and then go to the boards manager. Now it will download some platform index. As you can see, downloading platform index. So it will take a time. So friends, as you can see, the process is completed. Now simply here we want to search for ESP32. So ESP32, as you can see, ESP32, and then ESP32, this package, ESP32 board included in this package, simple ESP32. So just select it and click on install. Now it will install ESP32 packages for Arduino IDE. So process is started, as you can see. So it will take some time. Meanwhile, I will pause the video. So friends, as you can see, we successfully install ESP32 CAM drivers, or we can say the packages, on our latest Raspberry Pi Bookworm. Package install done. Now simply close the window. So now what we want to do, we want to configure the port with our Arduino IDE. So simply go to the tools, and then go to the board here in board, and in board you will see ESP32 Arduino, this one, ESP32 Arduino, and here we want to select ESP32 rover module. As you can see, ESP32 rover module. Let me show you again. So we have done with installation. We successfully installed ESP32 drivers, or we can say the packages. Now simply go to the tools, and as I already explained, I have connected the ESP32 camera module using a microcontroller USB programmer with Raspberry Pi 4 using our normal USB data cable. Simple. So I have connected the module, Now simply go to the tools, then go to the board, and then you will see ESP32 Arduino like this way. This is the option, and then here you want to select ESP32 ROR module. So selected ESP32 ROR module. So we select a board. Now again go to the tool. So it will take some time because same time I am recording. So now again go to the tool. So we select our board, as you can see. Now we want to select the upload speed. So go to the upload speed and select the upload speed 115200. This one 115200. So just select it. Done. Now again go to the tools, and then we want to select the partition scheme. So just go to the partition scheme and come out here, and then here we want to select huge app 3 MB no OTA 1 MB SPI double FS. This one option, huge app. So in partition scheme select huge app. So just select it. Done. Now again go to the tools, and then the last option, which is the port. So in port section, as you can see, you will see /dev TTY USB 0. So right now I have only connect the ESP32 camera module using USB cable to Raspberry Pi 4. That's why the USB 0. Suppose if you connect any USB devices, so you will see here the number is basically increased. You will see USB 1 or you can see USB 2. So basically you want to check how many USB devices is basically connect with your Raspberry Pi 4. This is how it's work. This is how it will show the /dev TTY USB. In your case it may be USB 1, it may be USB 2. So right now I have only connect the ESP32 camera module with the Raspberry Pi 4 using USB cable. So /dev TTY USB 0, this is what my port. So just select it. Done. Now again simply cross check, go to the tools, we select the board ESP32 ROR module, just like this way. Go to the ESP32 Arduino and select the board ESP32 ROR module. Then the upload speed we select 115200. Then we select partition scheme, which is the huge app. Then we select port, which is /dev /TTY USB 0. Done. So we select our board. Now we want to install a library for ESP32 camera module. So just go to the sketch, go inside include library, and inside our repository I have mentioned the zip file. As you can see, ESP32 cam main zip. This is the zip library which we are going to install inside our Arduino. So we want to select this library. So this library is basically inside our repository, which is ESP32 cam main zip. So just select the sketch, include library, select add.zip library. It will open the window like this way. So from this window we want to select our repository. As you can see, at the end we have our repository RPi4 ESP32 cam TF-Lite object. So just select it, and inside that we have our zip file. So ESP32 cam-main.zip, just select it, click on OK, and then it will install our library. And as you can see, the message library added to your libraries, check include library menu. So now simply open again our file manager, and go to the home, and then you will see there is a Arduino folder. As you can see, click on Arduino folder, go inside library, and then you will see this is what the folder which we just installed, ESP32 cam main. As you can see the folder. So just click on the folder, go to the examples, go to the Wi-Fi cam, and then you will see Wi-Fi cam.ini. This is the sketch file of Arduino IDE. Simply double click on the file, it will automatically open the file with Arduino IDE. But first let's just close our Arduino IDE. Just close it, close all the things, and open our file. Just double click, and as you can see now it's opening the sketch with the help of Arduino IDE. So friends, as you can see, our sketch is open inside our Arduino IDE. So here in Wi-Fi cam, here we want to select our router SSID and our router password for connecting our ESP32 camera with our Wi-Fi network. So Wi-Fi SSID here, just remove my-SSID, and here you need to mention your router SSID. So let's just say Apex, and the Wi-Fi password. In Wi-Fi password section, you need to mention your router password, just like this way. Simple. So let me mention my router SSID and router password. That's it. This is the things you want to mention. Then there is no need to change anything inside the code. That's it. So friends, I have mentioned my router SSID and my router password. After that, there is no need to change anything from the code. Simply click on upload. As you can see, click on upload, and now it will upload sketch inside our ESP32 cam. As you can see, compiling the sketch. So process is started. So friends, as you can see, compiling sketch process is completed, and it's detected our ESP32 camera board, and now it uploading our sketch inside our ESP32 camera board. As you can see, the process is started. It's already done 35%. So friends, as you can see, we have done 100% completed. Now leaving hard resetting via RTS pin. So now we want to reset our ESP32 camera board. Before we reset our camera module, let's just open our serial monitor. So just go here, click on serial monitor, and it will open our serial monitor like this way. And here we want to select a baud rate which is 115200. This one 115200. Remember one thing, do not close a serial monitor. Do not close the serial monitor, because inside this serial monitor, when we reset our camera module, we can see the IP address of our ESP32 camera module. So do not close the serial monitor. So friends, we're done with compiling sketch inside our ESP32 camera module, and as you already see that we want to reset our ESP32 camera module. So for that, here it is. As you can see, there is a simple button backside. We want to simply push for the second. So just push the button like this way, just push adjust for second, and then just release. After that inside our serial monitor, as you can see, there is a IP address. Because we reset our ESP32 camera module, so it will basically reboot, and then inside the serial monitor, as you can see, there is an IP address. So 192.168.0.105 is basically IP address of my ESP32 camera module. That's it. So now simply again we are going to move on our desktop. So friends, now this is what our IP address. So we want to mention this IP address inside our browser. So open browser and mention the IP address 192.168.0.105, and then just hit enter. It will open this kind of window, as you can see, and here we want to select the resolution. So resolution which we want to select, which is 800 by 600. As you can see, the 800 width and 600 is the height. So just select it, and it will open the window like this way. As you can see, this is what a first image which we capture with the help of ESP32 camera module. So if you refresh, as you can see, it's continuously capturing images. Simple. As you can see, it's continuously capturing images. So it means we successfully configure our ESP32 camera module with our latest Raspberry Pi Bookworm. So now we want to connect this camera module inside our TensorFlow Lite code, the Python code. For that, first we want to install OpenCV, then we are going to install MediaPipe for TF Lite. So inside our repository, again let's just close, because we have done with Arduino side, so let's just close all these things. Just close it, click on no, and then just close all these things. Now simply again open File Manager and go to the repository. This is what our repository, and inside that repository again open rpy4.txt file with the help of text editor. As you can see, now this is completely fresh installation of our Bookworm 64-bit version. So first we want to run this command, the last command. So just copy the command and open the terminal. Let me explain here why we want to run this command. So if you try to install OpenCV-Python, because if you want to install MediaPipe, first we need our OpenCV. So sudo pip3 install OpenCV-Python. If you hit enter, then you will see an error. As you can see, this is what error. So for that we want to run this command. So just at the end copy the command and paste inside the terminal and then just hit enter. Then now if we try to install sudo pip3 install OpenCV-Python, there will be no error. There will be no error. As you can see, it started our process. So it will install OpenCV on our latest Raspberry Pi Bookworm 64-bit version. So friends, we have done with OpenCV Python. Now simply clear the screen and install MediaPipe. So sudo pip3 install MediaPipe. Sudo pip3 install MediaPipe and then click on enter. And as you can see, now it will install MediaPipe. So friends, as you can see, we have successfully installed MediaPipe on our latest Raspberry Pi Bookworm 64-bit version. So friends, as you can see, I have disconnected ESP32 camera with Raspberry Pi 4 because of we connect our ESP32 camera module with our Wi-Fi, so we can simply use our ESP32 camera as a network IP camera. So I have connect ESP32 camera separately using a power adapter. As you can see, this is what the power adapter, and this is our normal USB cable. As you can see, this is what our normal USB cable. It's look like this way, and which I have connect with ESP32 camera module using our USB microcontroller programmer. As you can see, so let me show you like this way. As you can see, I have connect the cable with camera module like this way. Simple. So now simply we can access our ESP32 camera module as a network IP camera for our TensorFlow Lite object detection. That's it. So friends, as I already explained how I have connected the ESP32 camera module separately using a power adapter. Now I have power on the power adapter and ESP32 camera module is on. So now simply we can try to ping with our camera module. So IP address is 192.168.0.105, which we already checked. So 192.168.0.105. if I hit enter, and as you can see, we are successfully communicating with our ESP32 camera module because it's pinging, there is a result. Now simply again we want to open our browser and let's just open 192.168.0.105. if I hit enter, and then this is what our web page. Simple. And here we want to select 800 by 600. This is what the width and height. So if you refresh, and as you can see, this is the live images. Simple. So now if you open our repository again, inside that I have mentioned the code for accessing our camera module as a network IP camera with the help of OpenCV for testing purpose. So ESP32TST.py, just open with Tony Python IDE. It will open the code with Tony Python IDE. But because this is completely fresh installation, so we want to switch to regular mode for our Tony Python IDE. So let's just click on switch to regular mode, click on OK, and then close it. And now again open the code with Tony Python IDE. That's it. We open our code. Now then, here, this is the link. Let me show you again. Just open the new tab, mention the IP address of ESP32 camera module. In your case, of course, it will different. So mine is 192.168.105. Then just hit enter. It will open this kind of page. Then select the 800 width and 600 height. Select it. It will open the first image. Then you need to copy this link. Just copy the link as it is. Just copy it. Just copy. Open the code and in URL section just paste the link. Just paste it. In single quote, just paste it like this way. This is the link which we want to copy from our browser as it is. Just copy and paste here and then just save it. And now if you run the code, and friends, as you can see, now we are accessing our ESP32 camera module as a network IP camera. As a network IP camera with the help of our OpenCV. Simple. So we have done with testing. Now simply stop the code and now we are going to simply open our TensorFlow Lite code. So inside our repository, we have detect.py and this is what our by default pre-trained module for TensorFlow Lite which I have mentioned, and we want to simply open our detect.py. So just open detect.py, just right click. There is no need to open with editor. We want to open our detect.py, of course, with our Tony Python IDE. So right click, click on Tony, and it will open detect.py with the help of Tony Python IDE. So this is what our code. And here it is. As you can see, I have mentioned the URL, the same URL, same way. Just copy the URL from the browser, copy it. Let's just cross check. If you refresh the page, as you can see, it's capturing images. It means we are successfully connected. So now simply just copy the link, open Tony Python IDE, and here in URL, just remove the URL and just paste the new URL and just save the code. And if you run the code, and friends, as you can see, it's detecting object, it's detecting chair. Simple. Because as you can see, I am same time recording with the Raspberry Pi 4, so that's why it's slow. It's detecting me as a person, it's detecting the chair. So we successfully configure ESP32 camera module as a IP camera, and we are accessing our ESP32 camera module inside our Raspberry Pi 4 for TensorFlow Lite object detection. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.